the slope of the line. So lines have the form y equals mx plus b, right? Where m is the slope and the b is the y-intercept. I'm just going to write my equation on my line right now. So my y-intercept is, we're crossing the y-axis, which is at positive 4, right? So that's plus 4. Now we need our slope. So we find 2 points that are within one right after another, consecutive points, and then we do the rise over the run, right? Yeah. So we went up 1, 2 over 1. So that was 2 over 1 x. So we would write y is equal to 2x plus 4. How many got that part right? Awesome job, guys. Good. So then we say, okay, so our slope was 2. Okay, I'll get started. So first of all, today we're going to be figuring out the average rate of change on a function over an interval. So we're going to be finding the average rate of change over an interval of a function. So it does have some similarities to slope, so I want to make this connection so that hopefully it's not so hard for you guys. It's not super hard, but it tends to be because students kind of can't make the connection. So I just want to remind you of what we just did, because finding an average rate of change is very similar. Okay, so we have 2 points, x, y, x, y. Here's our first point, here's our second point. We know that we can find the slope by doing rise over run, right?
Yes, sir.
Which is really just the change in y over the change in x. Or really, the formula for that, which you should have learned in secondary math 1 or even before that, is y2 minus y1 all over x2 minus x1. That's where the rise comes from, is y2 minus y1 all over, and the run comes from x2 minus x1. So you can always find the slope using this formula, okay? Now understand, guys, these are just xy points, right? So right here, if I said find the slope between these 2 points, xy, xy. So this is my first point, this is my second point. Now the reason this is my first point, isn't it from left to right the smallest?
Yeah.
Okay, now look, isn't my x value smaller here than here? That's why this is my smallest. That's why it's my first point. Okay, so let's find the slope. It's y2, or could I call this, hey, couldn't I call this f of x2? The function at x2, right? So I'm making a connection here for you guys. And then couldn't I call this f of x1? Right? Isn't that what y1 means? The function at x1. Okay, sweet. So we're doing y2, or f of x2. So instead of writing it like this, let's write it like this. F of x2 minus f of x1. Isn't that y2 minus y1? All over x2 minus x1. Okay, so f of x2 was 8. So we're doing 8 minus f of x1, 8 minus 5, all over x2. Sorry, that was y2, right? y1 all over x2, which is 3 minus x1. So our average rate of change, or the slope, because it's a line,
3 over 1.
will be 3 over 1, so it's 3. So our slope's 3, and that's also the average rate of change. So isn't the average rate of change is really just the slope.
Okay.
But the problem is, the reason we don't always say that is because, do parabolas have slopes? No. But the average rate of change formula is still the same, but it's not a slope. Because slope means constant, right?
So can you can figure this out with just any points?
Yes. Yep, so it doesn't have to be, so that's why we don't say it's the slope, because not all equations have slope. Nevertheless, it will be this formula. So here it is. Here's the formula. F of b minus f of a all over b minus a. Okay, so we're going to be finding the average rate of change on an interval from a to b. Now understand, this interval from a to b is really two x values, because it's saying an interval from a to b. So this is between x is equal to, this is my x1, and this is my x2. So we're looking at an interval. What's the average rate of change? So just think about it. So just think about it real quick with me for just a second, then I'll answer whatever question. So don't forget it. I'll come back to you, okay? So if this is my x1, a, then will this y be f of a?
Yeah.
And then if b is x2, then will f of b be my y value?
Yeah.
And then it's just y2 minus y1 all over x2 minus x1, which is f of b minus f of a all over b minus a. So do you see how it relates? F of b minus f of a. Isn't that the same thing as y2 minus y1? Yeah. Do you guys see what I'm saying? So it's very similar, it's just we don't call it a slope, because this is, may or may not be a slope. Like, slopes are only lines. Okay, but do you guys see how they relate? F of b, that means our function at b, minus f of a, our function at a, all over b minus a. So a is our lowest x value, and b is our highest x value. Okay, questions? Okay, So the reason I showed you all that stuff before is just so that you can make sense of this formula. So our function at b minus our function at a all over b minus a, where a is our lowest x value and b is our highest x value. So it's on an interval between those two x values. So let's do our first example here, guys. Here we go. So it says, find the average rate of change for the function f of x is equal to 2x minus 4 on this interval between 0 and 7. So this is x is equal to 0 and x is equal to 7. Does everybody understand that? So my a value is 0 and my b value is 7. Because a is the lowest value and b is the highest x value. Are we all comfortable with that? So now we know that we want to do the formula to find the average rate of change f of b minus f of a all over b minus a. So don't we need to find our function at a and our function at b to plug it into the formula?
Yes.
Okay, so let's do that. Let's find f of a. So we're finding f of a. Isn't that f of 0? So we're finding our function at 0. So f of 0 is 2 times 0 minus 4, right? 2 times 0 minus 4. What's f of 0? What's f of a?
Negative 4.
Negative 4. So is everybody comfortable with that? We're all good? Let's find f of b so that we can plug it into our formula. What's our function at b? Isn't that what that means? What's our function at b? So what's our function at 7? Let's figure out what that is. So our function at 7, guys, we're plugging in, that's f of 7. So 2 times 7 is?
14.
14 minus 4 is? 10. So f of b is 10, right? So we need these for our formula. Here we go. So we're doing f of b, which is 10, minus f of a. F of a is?
Negative 4.
Negative 4. So I do 10 minus, this is where most people mess up. It was f of b minus, and then f of a is negative 4. So everybody comfortable with why it's minus the negative? All over b, which is 7, right? Minus a, which is 0. Questions on where I got any of that stuff? Okay, we're almost done. On top, 10 minus negative 4 is positive 14. All over 7 minus 0 is 7. Now you can't just type that into your calculator right there, you'll get it wrong. You have to calculate the top, calculate the bottom, and then divide. Does everybody understand that? Okay, what's 14 divided by 7?
2.
2. So our average rate of change is 2 on the interval from 0 to 7 for that function. So that was the average rate of change. This one is a slope, isn't that a line?
Yeah.
So that was just y2 minus y1 all over x2 minus x1. Questions? Okay, let's do another one. Okay, find the average rate of change for this function, 3 minus 2x squared on the interval x is equal to negative 2 and x is equal to 4. So isn't a your lowest x value? So a is negative 2 and b is 4. So now to do our formula, which we know is f of b minus f of a, our function at a, all over b minus a. We need f of b and we need f of a. So let's do that. We're finding f of a. So aren't we really finding f of negative 2? Because a is negative 2. So we're finding our function at negative 2. I'm going to show my work for this one. So I'm going to do that right down here. So we have 3 minus 2 times, we're plugging in negative 2, so negative 2 squared, right? You have to use parentheses today, people, or you're going to get it wrong. Anything squared, no matter what, has to be in parentheses. So let's type that into our calculator, or we could just calculate it by hand. Go ahead and calculate that for me.
Negative 5.
Negative 5, okay? So our f of a was negative 5. Are we all comfortable with f of a being negative 5?
Okay.
Did you guys type it in? Okay, so those of you that didn't type it in, make sure you're typing it in, because we've got to practice. Okay, let's find f of b, which we know means f of 4. So what's our function at 4? So that'll be 3 minus 2 times 4 squared. Parentheses really matter. Go. What's f of b? Negative 29. True. So now let's plug that in. Now guys, this is what we need for our formula. We need a and b, we need f of a and f of b, right? So f of b is negative 29 minus, make sure you put in your minus, now look with your eyes. What's f of a?
Negative 5.
So minus negative 5. Are we all comfortable? Like, people will look too soon and they'll just put 29 minus 5. That's way different than 21 minus negative 5. All over b minus a. b was 4, and then minus a. So a is negative 2. Don't mess up on the subtracting of negatives. So on top we have negative 29 plus 5. Right? What do we get?
Negative 24.
Negative 24. And then we have 4 minus negative 2, so that becomes...
60.
So our average rate of change is
Isn't it minus -5?
Yeah, so we went minus -5, so that's why we changed the, yeah, good questions. So then we added 5. So our average rate of change was -4. So our average rate of change was -4. Does that make sense? On the interval from -2 and 4. So the reason we don't always say, okay, it's just the slope, it's not, this doesn't even have a slope, right? It's quadratic. Quadratics have accelerations. But average rate of change works out to be the same formula. -4. Questions? So what if I asked you which rate of change is larger, -4 or this one too? Which one's larger?
2.
Is the average rate of change larger on this function or this one?
2.
Which ones is the average rate of change larger on?
2.
4, right? Even though it's negative, so this is a common way of thinking. People say, well, 2 is larger than -4. But let's think about it. It's changing on an average of 2, right? This one's changing on an average of -4. So which one has a greater rate of change? Does that make sense? -4. Yeah, so that's why we went over it, because yeah, that's a common thing. So just make sure you're careful with that. Because we're changing by 4, right? Even though it's negative, it's still changing by 4, which is greater than 2. Is everybody comfortable with why? Okay, sweet. Let's do another one. So find the average rate of change. I promise you'll be able to get this done in class, so really stay with me for just a couple more seconds. Find the average rate of change for the function on this interval. So my a value is -1, my b value is 1. Let's find f of a. So when we be plugging in -1. So we got to be really careful. We've got to be good today. So we have negative, parentheses, -1 minus 2 squared plus 4. You've got to type it into your calculator exactly as such. Okay? So we have a negative in front. That's -3 squared plus 4. So that's -3 squared is +9, right? So 9, then this minus in front is right there plus 4. So we should have got -5. Did we get -5?
Yes.
So f of a is -5. Let's find f of b. So we're plugging in our function b at b, which is 1. So we're doing -1 minus 2 squared plus 4. So by hand, that's negative, and here's -1 squared plus 4, right? Or you could just type it in like that to your calculator as long as you use parentheses. So that's negative in front, and then -1 squared becomes 1. Plus 4, which is 3. Okay, so f of b is 3. So now we'll do our formula. The average rate of change, f of b minus f of a all over b minus a. So f of b was 3 minus f of a, which is -5, all over b, which is 1, minus a, minus -1. Am I going too fast? We're all good? So on top we get an 8, right? On bottom we get a 2. So our average rate of change was 4 on the interval between -1 and 1. So which average rate of change is greater, 4 or -4?
They're the same.
They're the same, right? Even though the one's changing by -4, it's still changing by it's still changing by 4, right? Because of the context of the problem. Do you understand that, everybody? So the average rate of change between this function and this function is even. They're the equal, the average rate of changes. Okay, but 4 is not equal to -4. The average rate of change is in total 4, but our average rate of change was -4 and 4. Did I just confuse anybody? We're all good? Okay. Last 2 problems, the rest of the time is yours. You will finish in class as long as you fully understand and aren't making errors that people make when they get started too soon. So it says, find the average rate of change for this function, this picture, on the interval between -8 and 6. So we know our a value is -8, right? Our b value is -6. Are we all good? So now to find the average rate of change, I need f of a and I need f of b. Think about what this means, guys, okay? So f of a means what's our function at a? A is -8. What's our function at -8? Isn't that what f of a means? What's our function at -8? So let's look. -8. What's our function at -8? At -8, our function is at 5. So our function at -8 is at 5. Does everybody understand that? Our function isn't this x value -8? Your function isn't, where's your function at -8? Boom, right there at 5. Does that make sense? Okay, so where's our function? And once again, our function at b, so we're really looking, what's our function at -6? So you'll look with your eyes. Find 6. It's negative 6, right? Where's our function? Negative 6. So there's negative 6. Where's our function at negative 6? Negative 3. Does everybody see that? So negative 3. So then now we can just do our formula. This one was easy. We're doing f of b minus f of a all over b minus a. So f of b, negative 3 minus f of a. F of a was 5 all over b, negative 6 minus a. A is negative 8. So on top we have negative 8 because negative 3 minus 5 more is negative 8. On bottom we have negative 6 minus negative 8, so that becomes positive 2. Our average rate of change on the interval from here to here was negative 4. Does everybody understand? Okay. We're all good? Okay, last one. Find the average rate of change on the function. This is the function on the interval x is equal to negative 3 and x is equal to 1. So my a value is negative 3, my b value is 1. To find the average rate of change, you need your function at a. So that's our function at negative 3. We need our function at b, so that's our function at 1. So look with your eyes. This one's easy. So what's our function at negative 3? Negative 8.75, right? Isn't that our function at negative 3? So that would be negative 8.75. F of b, what's our function at 1? Negative 7.75. So then we're doing our formula f of b, which is that, negative 7.75 minus f of a, so minus negative 8.75 all over b, which is 1, minus a, which is negative 3. So then we would quickly calculate that. So we get, on top we get 1, and on bottom we get 4, 1/4. Our average rate of change from here to here on that interval was 1/4. Does that make sense, everybody? Questions? So you're all good. Get them right. Don't mess up on the minusing and negatives and stuff, okay? Sweet. Finish the worksheet. You'll need some paper. It's when you're like squished together is when people mess up, and it's just not worth it. Because I'm going to ask you if you like get it wrong, well, what'd you get for f of b? Because that, you know what I mean? That's easier to check. Show your work.